All right. Okay, let's look at exponent rules and the connection with logs. Okay, because I think people don't realize logs have jobs, and so all functions have jobs, right? Square rooting will undo area to give you a side length. Squaring gives you the area. Absolute value spit out a distance from zero. Either you went +5 or -5 from zero. You know what I mean? So every function has a job. And so logs, remember, so if you have, say, whatever, I don't know, 2 to the 4th power is 16. Remember, the job of a log is to eat the answer and to spit out the exponent. And then the base just comes down here because the base changes. But the job of a log is to spit out an exponent. So if this is an exponent, all of this is an exponent as too, right? If this equals an exponent, that has to. So your exponent rules, if you know those, you know your log rules, okay? Because they're intimately connected. So remember when you were younger, if you have a problem like this, you would add exponents. Now, again, I don't want you to just be like, well, I forget. When do you multiply? When do you add? Well, think about it. This is 1, 2, 3, 4, 5, 6, 7 eighths, and then 2 more. And they're all getting multiplied. And so in this scenario, you are just counting x's. The reason you add them is because you're counting. And if you remember as a little kid, how did you learn to add? You counted. You took 8 of something, and you took 2 of something and you counted 8 and then 9, 10. Okay. So when you count, you are adding. Okay. What about if you have a power to a, oh boy, Julie, sorry about that. A power to a power. Okay. Well, this means I have 2 sets or 2 groups of that. So this means I have x cubed twice. Now you're counting, right? Because now you have written it out. But initially you were doing 2 groups of 3. So here you multiply and get x to the 6. So when you're multiplying, you add exponents. When you take a power to a power, you multiply. Now again, this goes back to you when you were a little kid. If you have 2 sets of 3, that is the definition of multiplication, right? You have 2 sets of 3, that is multiplication. Now, can you draw it out and, count if you want to? Absolutely. But the definition of multiplication is sets or groups, okay? The last one, and again, you might have memorized this, but I don't advocate for that, is here. When you're dividing, you subtract exponents and you get x to the 6. Now again, why are you subtracting? You have 8 x's being multiplied up here. What's that? 6, 7, 8. These are all being multiplied. And then you have 2 on bottom in the denominator. So why do you subtract? Because you are canceling. You're dividing those out. X divided by x is 1. X divided by x is 1. And you have 6 left, okay? So why do you subtract? Again, if you have 8 cookies, 4, 5, 6, 7, 8, and you cancel 2 of them, that is subtraction. You're getting rid of 2 of them. So as a little kid, when you learn subtraction, it's when you get rid of stuff, okay? Here, the reason you're getting rid of the stuff is because x divided by x is a 1, and x divided by x is 1. You're canceling. All right. So with logs, we are going to use those exact same rules, okay? And so we're going to expand or condense. Okay, so say I give you log base 3 of 4xy. Okay, so you have 3 things in here, 3 factors, right? The 4, the x, and the y. So what you're going to do, and this is called, we're going to expand it out, and we're going to use exponent rules, okay? Because that's what this is spitting out. So you're going to write log base 3, log base 3, log base 3. So when you expand, if I have 1, 2, 3 things here, you write it 3 times, okay? All right, this is what? A multiplication problem. Okay, so again, you have to think, okay, so when exponents are being multiplied, what math do I do? Oh, I add them because I'm counting. So this is all going to be add. You're going to put a 4 here, an x here, and a y. Because again, when do you add exponents? It's when it's a multiplication problem. Okay, so when it's a multiplication problem, you add. So if you're going to expand it, you are going to do that. Okay. What if I give you log xy over 2 and I ask you to expand? Okay, now if there's no base, this is base 10. Okay, kind of like square root. If I don't write it, it's square root. If I want a different root, I would do 5 to get a 5th root. All right, so the default here is 10. If this was natural log of xy over 2, the base would be e, okay? Because again, natural log means your base e. All right. So again, how do I expand? I have 1, 2, 3, 1, 2, 3. So you're going to write the word log, 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 or if it's natural log, you write natural log, natural log, natural log. Okay. What's happening here? I am multiplying. Okay, so if you have a multiplication problem with exponents, you really add. So these two I'm going to add. So this is going to be x plus y. Now, this is division. Okay, so think of exponents. What do you do when you're dividing exponents? You really subtract. So I'm going to put minus 2, and that one's expanded. And then, of course, this is just the same. It's just natural log. Okay. Now, be a little cautious there. If I give you, say, natural log of, I don't know, x, y, and w, z, everything in the numerator, these are multiplied, so those are both added. And do you see how I need to write ln 4 times? Because I have 4 things. So ln and ln. Both of these are in the denominator, so they're both subtract, minus, minus. Okay, because I'm dividing by both of these. Now, could you write this as ln of x plus ln of y minus, and then do ln w plus ln z? Yeah, but you're going to distribute that anyway. Okay, so they're going to both end up being negative anyway. If you're like, well, I don't quite get that, Julie. Well, again, things in the denominator are negative exponents, right? They're reciprocals. So if I write it all on one level, you can see that this is a negative exponent, so is that. So these things have to have negative coefficients, okay? All right, now let's combine kind of everything. All right, so say I give you natural log, say I give you x squared, and then I give you, I don't know, x minus 1 cubed or something like that. Okay, all right. So if you look at this, I have one piece up here, one piece here. So I have ln of, and then I'm going to have that, and this is division, so it's going to be subtract ln of that. Okay, so I have x squared here, x minus 1 cubed here. Now, that is wrong, because when you do this, when you expand, you can only have a single thing in here. Notice I just have an x, just have a y, just have a 2, just have an x, just have a y, just have a w, just have a z. We have exponents. Well, that's where that other rule comes in. Remember, a power to a power, you multiply, because you have 4 sets of 2. You have 4 sets of it. So that's why you end up, how about if I write 8? Sorry. 4 sets of 2 is 8, and you can see it. Okay, so you can't have exponents. Well, when you have a power to a power, what do you end up doing with them? Multiplying. So this 2 is going to come down as multiplication. This 3 is going to come down as multiplication. Because again, logs are really exponents, okay? What they spit out. Logs eat answers and spit out exponents. So this is eating an answer and spitting out an exponent. So is it? So exponent rules work on this thing, okay? All right, let me do one more. And then say, I don't know, we'll do log base 2, this one, and we have what? X squared plus 1 all over x cubed, x plus 1 to the 4th. Okay. All right, so how many chunks do I have? I have 1 chunk here, 2, 3. So I'm going to write the word log 3 times. All right, this goes in this one to begin with. Now, square roots are really half powers. So I'm going to write that because that's really an exponent in disguise. That's to the half power. This guy, x cubed, and this one, x plus 1, and that is to the 4th power. Okay, now the exponents have to come down. So this is going to come down in front. And then this is going to come, and that's adding, right? No, that's subtracting, because that's in the denominator. Do you see that? This is all being divided. So that's that's minus, because it's down here. But the 3 is going to come down. And this guy's also in the denominator. So he's also minus subtraction, and the 4 is going to come down there. Okay. And then that's all I can do, because this is my chunk. This is my term. It's a big piece there. I can't do anything else with those, okay? All right, now you can go backwards, all right? So I could ask you to, what we would say, condense, okay? Now with condensing, say I give you log x minus log y plus 3, a natural log of z minus natural log, say 4 natural log of w, something like that. Okay, So this time it's the opposite process. I have it written 4 times. You are only going to write it once because you're condensing it into the one. Now, for you to condense it in one, they all have to be the same base. Okay, so if these were base natural log and these were base 3 of log, you'd have to do 2 separate problems here. All right, but they all have the same base. They're all natural log base E. All right, I'm going to draw my fraction bar. Anything with a positive coefficient is in my numerator. This is x to the first power, positive. It's up here. This guy's positive. So the z's up here. Now notice I'm going to go backwards and put the exponent back in. So that would be z cubed. Again, anything that's positive is in your numerator. Subtraction, when do we subtract exponents? When we're dividing. This is subtraction. So this is in the denominator, and this is subtraction. So bring the 4 back up as an exponent. We're going to undo all that math and bring it down there. Okay. All right, let's see if I have, sometimes we can do these with numbers with condensed where you don't need a calculator. So say I give you 2/3 natural log 8 minus natural log of, let's say, I don't know, what do I have? 5 squared minus 1. I think that's right. Yep. Okay, and it might say solve without a calculator. All right, so I can do all of this in one. Let's go ahead and do this. 25 minus 1 is what? 24, so I'll rewrite that. And then let's bring this exponent back in. So I'm going to bring that 2/3 up there. Okay. Now, if you don't know what 8 to the 2/3 is, let's separate it out. It's 8 to the 2 times a third. Okay. So there's 2 ways to think of it. It's definitely either 8 squared and you cube root it, right? Because this is a fraction, that's a cubed root. Or you could do the cubed root first, cubed root of 8, and then square it after the fact. So kind of whichever is easier. This is 64 cubed root. You may or may not know. This one, the cubed root of 8 is 2 times 2 times 2. So that's going to be 2. 2 squared is 4. Either way, you're going to get an answer of 4th for this. Okay, so I know that's 4. And that's after I do the log, minus ln of 24. Okay, and then let's see. Trying to think if there's anything else we need to do here. Oh, helps if I write the ln there. All right, okay, so now I have what? Subtraction, okay? So now let's see, I would put it, I'm going to condense it into 1. This is subtraction, so I'm going to divide. This is the top, that's the bottom, so ln of 1/6, okay? If Newton or My Math Lab or whatever you're using likes that, you could do that. Probably, it's kind of bizarre, I know, but it probably wants you to go back and say, oh, well, write that as it's division, so let's write it as subtraction. And the reason is this, the natural log of 1 is always going to be 0. So negative ln of 6 is probably a prettier answer. And the reason to this is base E, and remember anything to the 0 power is 1. So if you have natural log anything that equals 1, like log of 1, right? Even if this is, say, base 5, 5 to the 0 power is 1. Okay, so anytime you have a natural log of 1 or just a normal log of 1, the answer has to be 0. So this is probably the final answer they're going to want. Okay, so you might be like, why? Well, it's because of this thing. All right, let me do a couple easy solving. And then in another video or let me do some log kind of tricks of the trade, I guess. Let me pause for a second. I'll show you those. All right, let's do these without a calculator. So if you know what logs do, right? Logs eat answers. So the answer is 16. So what is that? 2 to the 4th power, I know is 16. So I know that answer is 4 without a calculator. Here, this one might be a little trickier. You're like, okay, my base is 3. What power gives me 1 over the answer? It would have to be a negative exponent to flip it. So that would be what? Negative 3? Because 3 times 3 times 3 is 27, but it's reciprocated. All right, now these are kind of more rules. Think of this. 5 to what power equals 5? Well, that's going to have to be 1, even if it's 6, 6, whatever. Here, these kind of cancel out, and you get a 7. These cancel out, you get a 7, okay? And this is the one I talked about, because logs and exponential are inverses, so do you see those kind of cancel out, and you get the 7? They don't kind of cancel out. They do cancel out. Here, remember I just talked about a little bit ago. This is your base, and anything to the 0 power is 1. So if you have a log of 1, doesn't matter. It could be log base 3. it's still going to be 0 because any power to the 0 power or any number to the 0 power is 1. So log of 1, regardless